Now let's take a look at the Pythagorean Theorem side of your notes. So I'm looking at what seems to be a right triangle here, Pythagorean Theorem side, but I need to add something pretty important. That little box on the left-hand corner, that little box means that there's a right angle right here. So right angle, 90 degrees. And I need that 90-degree angle in order to have a right triangle and in order to use Pythagorean Theorem. Once you have a right angle in a triangle, you can name the various parts, the various sides of the triangle. The side across from the right angle is always called the hypotenuse. Hypotenuse. And it is always the longest side. So it's always across from the right angle, and it's also the longest side. The other two sides are called the legs. So here's one leg, and here's the other leg. So we learned a squared plus b squared equals c squared. What that really means is if you take the length of one leg and square it, multiply it times itself, take the second leg and square that, add the two squares together, you will get the same amount as if you take the hypotenuse. The sides of the hypotenuse and square that. So a squared plus b squared equals c squared really means leg squared plus leg squared equals hypotenuse squared. You use Pythagorean theorem for two things: to find sides of right triangles. So if I give you two sides of a right triangle, you can use Pythagorean theorem to find the third side, and also to decide if a triangle really has a right angle in it, if it is actually a right triangle. So you can also use Pythagorean theorem to decide if a triangle is right. And there's actually a way to use Pythagorean theorem to decide if a triangle is obtuse or acute, and we'll be doing that later on this year when we come back to doing some more stuff with triangles. But today we're just going to deal with right triangles, and actually we're only going to be working about remembering how to find sides of right triangles that are missing. So that's what our examples are about. Let's take a look at them. Find the missing sides of these right triangles. Well, I'm going to write down my formula that I know I'm going to be using, and that's going to be leg squared plus leg squared equals the hypotenuse squared. And you can write a squared plus b squared is equals c squared. There's nothing wrong with that, but I'm finding that a lot of people forget where to put what part of the right triangle, and it seems to make a difference if I say leg squared plus leg squared equals hypotenuse squared. Seems to be a little bit more straightforward about where to plug in those numbers. So let's look at this guy, this first triangle. All right, x, that's a leg, and 2, that's also a leg. And I know that because together they are forming the right angle over here on the top. And 5, that's the length of the hypotenuse, and I know that because it's across from the right angle. So leg squared plus leg squared equals hypotenuse squared. X squared plus 2 squared equals 5 squared. And now we're just solving an equation that has an x squared in it. So let's do that. 5 squared is 25. 2 squared is 4. So now my equation is x squared plus 4 equals 25. I'm going to subtract 4 from both sides. Now I have x squared equals 21. And the last step is going to be to take the square root of both sides. So x equals plus or minus the square root of 21. Now I've got two things to think about here. First of all, do I really need to worry about the negative square root of 21 answer? Yes, it works in my equation up here for sure, but does it make any sense to have a side of a triangle being a negative number? Probably not. So the only answer I need to be concerned with in this case is the positive square root of 21. I can ignore the negative one. Second thing I need to think about is, can I simplify this? Is there any number that will go into 21 and give me a perfect square or a pair of factors? And there isn't. I'm not going to be able to break this down any more than it is. So I am done. X equals the square root of 21. If I want to put that into the calculator, it's going to be some number, bigger than 4, right? Because that'd be the square root of 16. And less than 5. So it'll be 4 point something. But we'll leave it as the square root of 21. Let's try this one over here on the right. I've got 6, 4, and x. So once again, I'm going to decide where the hypotenuse is and where the two legs are. Well, it's sitting on the hypotenuse. That's the side across from the right angle, which means that these two sides are legs, the 6 and the 4. All right, let's plug it into leg squared plus leg squared equals hypotenuse squared. So 4 squared plus 6 squared equals x squared. If you are somebody who's just learning the Pythagorean theorem for the first time, you may also want to write it down. Leg squared plus leg squared equals hypotenuse squared. If you're somebody that already knows the Pythagorean theorem by heart, then while you're writing down the plugging in part, the 4, the 6, and the x, be saying leg squared, and hypotenuse squared, just so you're sure where you should be putting in the numbers or the x. All right, 4 squared is 16. 6 squared is 36. And x squared will leave as x squared. 16 plus 36 is 52. 52 equals x squared. I'm going to take the square root of both sides. And then once again, I'm not going to worry about the positive and the negative piece. The positive is the only answer I need because I'm talking about triangles here. The only other thing I need to ask myself is, can I break down 52? Well, let's see. 2 would go into 52. How many times? Twice. We have 4 and a 12. 6 times. So I'd have 2 and 26. Yep, I'm thinking that I might be able to simplify this. Let's try 4. Oops, sorry. 4 times what gives me 52? Pull up the calculator here. 52 divided by 4 is 13. The square root of 4 becomes just 2. And so my final answer is going to be 2 times the square root of 13. Done. Let's try one more. So here the 10 is a leg, the 4 is a leg. I know that x is the hypotenuse because it's across from the right angle. Leg squared plus leg squared equals hypotenuse squared. 4 squared plus 10 squared equals x squared. 4 times 4 is 16. 10 times 10 is 100 equals x squared. 116 equals x squared. And the square root of 116 equals x. I'll leave it to you to figure out if you can reduce or not. Reduce, question mark, question mark, question mark. And then the last one, 21 is a hypotenuse. It's across from the right angle. X is a leg, 15 is a leg. So leg squared, 15 squared. plus x squared, that's the other leg, equals 21 squared, that's the hypotenuse. 15 times 15 is 225 plus x squared. 21 times 21 is 441. And I'll let you finish up that one. Alrighty, so you'll want to take a look at the notes and make sure that they make sense to you. And any place that you're feeling in either this video or in the one before that you're confused about, make sure you bring some questions to class. There was nothing, oh, 2 more problems to finish on the solving for x side, the 3x squared minus 4 and the 5x squared plus 1. And 2 questions to finish on the Pythagorean theorem side. Is 116, the square root of that, reduced enough, or can you break it down anymore? And go ahead and finish this last triangle problem and find out what that missing side is. Email me if you have any questions.